All right, so we're going to start looking at how we can actually put some numbers to our data that we collect. So in this three-part section, we're going to talk about measures of the center and measures of spread of the data. So center is going to be kind of a different way we talk about averages. So we generally are going to refer to those as measures of central tendency. What is the middle? What is the average of our graph? Now these are all things that you probably have seen before. The most kind of common thing is what we call the average, or the mean, pardon me. So the mean is kind of the traditional average, where you add up all the numbers and you divide by some total, how many you have. So the way we write this, there is a symbol for mean, and the symbol for mean is typically x with a line over it. We call it x bar. This represents what we call the sample mean, kind of the mean of the sample. And this formula says it has this symbol, which is a summation symbol. So this means add up all the numbers. Whenever you see this little sigma symbol, this means add up. So we're adding up all the numbers and we're dividing by how many there are. This is the sample mean. So quite simply, if I want to find a mean, I'm going to add up and divide by how many there are. So in this problem, I have these different data values. So if I want to find their mean, I will add them up and divide by how many there are. So if I want to write this out, it's 6.5 plus 6.5 plus 9.5 plus 8 plus 14 plus 8.5 plus 3 plus 7.5 plus 16.5 plus 7 plus 8, all divided by 11. Now, if you want to try to put something like this in your calculator at once, you want to obviously make sure you have parentheses around your numerator so it calculates correctly. So adding up the top, I'm going to get 95 on the top divided by 11. So when I do 95 divided by 11, I'm getting 8.64. Now the reason I'm going to write it as 8.64, and this is the grams of fat in the thing, so my unit would be grams. The reason I go to 2 decimals, in general, the rounding rule is you always want to go to one more decimal place than the raw data. So since our data was 1 decimal, I want to at least go 1 past that, so I'm going to go to 2 decimals. If it was just like integers, 1, 2, 3, 4, then I would just go to 1 decimal and that'd be fine. Now, very often the mean is not one of our data values. Typically the mean is not one of our numbers. And another thing, if you add a big number or a small number to the mean, it will change the mean a lot. So if I ever add another cereal bar brand that had like 100 grams of fat, it would significantly increase the mean. Because if I added one that had 100, my new mean would be 195 over 12. And so 195 over 12 would take the mean from 8.64 to like 16.25. So you can see how much it would change just adding one thing if it's a really, really big value. So big or small values will definitely affect the mean. And typically the mean is not one of our values. Another kind of measure of the center we have is what's called the median. Now, median is generally just going to be the middle number, okay? So the big thing is if you have your data all in a row, then it's going to be the number in the middle. If it's an odd number of data, so if you have an odd number of data pieces, it's going to be the middle data spot. If you don't, you'll find the 2 in the middle, and you'll take their average. The big thing is you have to make sure that they are in order. So if you look at this is the number of tornadoes that have occurred in the U.S. over an 8-year period. If I look for the median, I have 1, 2, 3, 4, 5, 6, 7, 8. So I have an even number of data points. So I could just kind of count in from the ends. They're in order here. So I have 4 on each side, so my middle is right here. So my middle actually isn't a number, it's in between those 2 numbers. So my median, which doesn't really have a fancy symbol per se, we're just going to take those 2 numbers and take their average. So 764 plus 856 divided by 2 is going to be 810. And since this is number of tornadoes, our unit would simply be tornadoes. So we have 810 tornadoes. All right, so here's another set of data. Now this one is the number of items that they purchase at a grocery store. So we have 7 customers. So now if I start counting in, they're in order again, I should mention. When I start counting in equally from the end, I actually have a number in the middle. So the median in this case is just going to be that number. It's just 12 items. Because I had an odd number, that number in the middle is just going to be my median. Now the cool thing is medians are not affected by extremely large or extremely low data values. They pretty much stay the same. So for example, let's do the one we just had of the number of customers. 1, 7, 12, 15, 22, 34. And then let's say someone decided to buy a lot of items. They bought, I don't know, 10,000 items from the grocery store. Okay? Now, you would think that would change it a lot, but it really doesn't. If I count in equally, I have these 2 in the middle, so I'm really just finding for the median the average of 12 and 15, their mean. So that is going to be 13.5 items. So yeah, it went from 12 items to 13.5 items, but I added one that was 10,000. So if I did this with the mean would increase exponentially large. Well, the median changes a little, but not very much. Okay. Now, lastly, we have the mode. Now, mode is just typically going to be something we can do by finding the data point that happens the most often. This happens a lot with data that is categorical, that has words instead of numbers. So this is the data for the duration of number of days the space shuttle voyages for certain years. So if I'm looking for which number occurs the most, it looks like 8 occurs the most. I have 5 instances of 8, so the mode is simply 8. When you have multiple numbers that appear, like if I had 5 8s and 5 9s, then we could say it is they're both modes, or we could say neither are modes. So sometimes we'll say they're bimodal, there are 2 modes, or we'll say there are no modes. Okay, it just depends on what. So mode is the most typical case. This is really, really good for categorical data on how that works. Okay. Now the nice thing is, not necessarily for this is pretty straightforward, not too hard mathematical calculations, but when we start talking about measures of the spread, which we will, it's going to help if we can actually use some of our technology to help out with that. So for us, we're going to use Desmos, which is kind of the graphing calculator, the calculator we use these days. So we'll try to use that to find the mean, median, some other things, and it'll help us when we start doing our measures of the spread. So here is my Desmos graphing calculator. Hopefully you can see this. So I can actually put values into this calculator. What we have to do this is we have to use this functions key. So when I kick the functions key, I'll find lots of different statistical features. I can't actually access them here, but I can access them and show you. So if I hit it, it would look something like this. Where it would look something like I could find the function mean. That is under this functions category. And there will be a second video you can watch to kind of show you how this works, but I just wanted to kind of show you here. And then what I want to do is I'll have a parenthesis, and then I just have my block, and I could just put numbers 2, 3, 4, 5, 6. And my block and my parenthesis. So what will happen is if I type this in, it will find the mean of this list of numbers. So hopefully this is not too bad, and the measures of spread a little harder to calculate, but mean pretty okay. If you have questions, obviously, please let me know.